we're going to find the cube roots of a complex number, we're going to write all of the answers in the form a plus bi and then plot them in rectangular coordinates. We're given this complex number, negative 8 plus 8 times the square root of 3i. I'm just going to rewrite that here. We're going to go ahead and call that w. Next, we need to find the magnitude of w. Remember that the magnitude of the complex number is also equal to r. The magnitude is going to be the square root of negative 8 squared plus 8 times the square root of 3 squared. And then it gives us that the magnitude is equal to 16. So we can write w, this complex number, in polar form as w is equal to 16 times a negative 1/2 plus the square root of 3 over 2 times I, which is equal to 16 times the cosine of 120 degrees plus I times the sine of 120 degrees. Now we have our polar form. Using de Moivre's theorem, the three distinct third roots of w are going to be given by z sub k equals the cube root of 16 times cosine of 120 degrees over 3 plus 360 degrees times k divided by 3 plus I times the sine of 120 degrees over 3 plus 360 degrees times k over 3. This will simplify to 2 times the cube root of 2. Make that 2 a little bigger here. 2 times the cube root of 2 times the cosine of 40 degrees plus 120 degrees times k plus I times the sine of 40 degrees plus 120 degrees times k. Here we're going to let k equal 0, 1, and 2 to get our 3 cube roots. If we do that, we'll get that z sub 0 is equal to 2 times the cube root of 2 times the cosine of 40 degrees plus I times the sine of 40 degrees. Z sub 1 is equal to 2 times the cube root of 2 times the cosine of 160 degrees plus I times the sine of 160 degrees. And z sub 2 is equal to 2 times the cube root of 2 times the cosine of 280 degrees plus I times the sine of 280 degrees. And if you notice that each of these 3 roots has the same magnitude, 2 times the cube root of 2. That means the points corresponding to each of these cube roots are going to lie the same distance from the origin. That is, the 3 points lie in a circle with the center at the origin and the radius of 2 times the cube root of 2. Furthermore, the points are equally spaced on that circle. Now that we have our 3 cube roots, we're going to go ahead and plot those in rectangular coordinates. Here you can see our diagram. We've got our circle, and we've got our three cube roots plotted on that circle. Here's z sub 0, z sub 1, and z sub 2. Notice that these are equally spaced along this circle, and the radius of this circle is 2 times the cube root of 2.